Oi lads, it's Dan here today, bring you lot a lovely video. In today's video, we're going to take a look at why the sum of the first nth odd terms is equal to n squared. So this is a lovely proof, a very common proof in series, and we're going to take a look at it. But before we do, I want you lot to leave a like and subscribe. So the way we do it is we need to understand this. Before we can proceed further, we need to understand this equation in front of you, right? And the way we do it is we're going to test it a bit. So we're going to see how it works basically. So we're going to start with n is equal to 1. So if you do n is equal to 1, on the right hand side it should be equal to 1, and on the left hand side you should basically have the only one term, which is your first term. In this case it's going to be the first term is 1. Therefore we have 1 is equal to 1 squared, which is equal to 1. So let's look at the second term, n is equal to 2. So if you have n is equal to 2, on the right hand side, you're supposed to get 4, right? 2 squared. And here, basically, this is a summation. So you're adding the term. So if you're telling it to stop at the second term, which is 3, you are going to have 1 plus 3, which is equal to 4. And we can continue this trend as n is equal to 3. And as n is equal to 3, you are going to have supposed to end up with 9, because 3 squared is equal to 9. And what's the third term in this case? Which it's 1 plus 3 plus 5. It ends at 5. So you are going to have 1 plus 3 plus 5 is equal to 9. Therefore, we see a lovely trend here that it's when you take the n squared of anything and you just add the odd numbers up, right? The first odd numbers up, you are going to have the same answer basically. So you can represent it using this formula before you, which is very handy to solve a lot of complex series problems. So how do you prove it now? Now we got to prove it across all the n terms, not for the the first 3. We need to prove it for all the n terms, straight from 1 all the way to a million probably, or billion, depending on the situation. So how do we do that? We do it with the series, and we are basically going to represent this over here, as a series. So the reason why it looks like this is we are starting with 1. That's the first term, so k is equal to 1. 2k minus 1. Here I wrote 2n minus 1. If you put any number over here, you're always going to end up with an odd number. Think of it. If you have 2, you are always going to end up with an odd number, never a prime number. Never an even number. My apologies. You are never going to end up with an even number if you use this formula, 2k minus 1. Think of it. So if you're going to use 1, you are going to have 1. If you use 2, you are going to have 3. If you use 3, let's say, you are going to have 5. So you'll never ever have an even number. That's the point. And we're going to continue it all the way up to the n term, because it goes all the way up to the n term. So 2n is minus 1 is basically going to be the n term, because it's not going to yield an even number. So that's the idea. So this is the series you are going to use, and we are going to basically solve it using this series. And I'm going to prove to you why it's equal to n squared. So the way we're going to do it, same like we use for integrals, we are going to use a distributive property, I should say, for series. And it's the same type of property we're going to, we could use for integrals and derivatives. It applies over here. So we can use this distributive property, allowing us to basically distribute the series, and basically separate them as shown on your screen before you. It allows us to solve it. We're basically taking a more complex series, and this is allowing us to make it, to look at it in a simpler way, because if you look at it straight on, you're not going to be able to get to n squared. So we got to look at it from easier series. It's like a piece of a puzzle. You're going to have to break it into a simpler, it's a simpler way to solve it, because you can't just solve it straight on. So we're going to break it up into simpler, series problems to solve. And let's start with the first one, which is this. We have proved this in our previous video where we took a look at it, and this is a very straightforward series, very common one. This series basically states is, you're starting at 1 and you're adding you know, basically from 1 to the n term, and it's basically a summation. So if you have 10 over here, you're adding 1 plus 2 plus 3, blah, 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 all the way up to 10, because that's your n term. Let's, you know, just giving you like an example. That's basically the idea of that series. So in this case, we are taking it all the way up to the n term. Let's say infinity, just for the sake of this argument, right? So if you do that, we are basically, we can rewrite it as n being multiplied by n plus 1 divided by 2, and that's been proven in the previous video. So for now, you can basically say that, you know that it's equal. But if you want to see why it's equal, please check out my previous video, which I prove it in great detail. Right. So for this one, this series is a very straightforward series. This one's very easy because you have k is equal to 1, and here it's always going to be equal to 1. And you're taking the series just the sum of 1 each time to the nth term. So you can think of it like, perhaps, you know, you have, let's say your n term is 10, right? You know, you're going to have 1 plus 1 10 times, basically, which is equal to 10. So in this case, if you have it n times, you're going to have n as your answer, basically. So this series is just equal to n. If you have 10 over here, you're now going to have 10 over here. Simple as, right? So if we continue on, we can rewrite these two series as the formulas, you know, so it's just going to be a lot easier to solve, and we basically eliminate the series from the, you know, the equation, and we can use basic algebra to simplify this. And when you do so, you are going to see that the 2's are going to cancel, all right? And then you are going to have n squared plus n minus 1. N minus n is equal to 0, so you are going to just end up with n squared, ultimately proving why the sum of the first n odd numbers is actually equal to n squared. So if you enjoyed this video, please drop a like and subscribe, and I'll see you later.